Hello everyone, welcome back. We are doing tension in cables, strength of materials and structures, N6. The diagram that you see on your screen is the diagram that I'm going to use to explain this whole topic and how it works. So here we have two supports. For now, we are going to call them towers. Yeah, let's call them towers. We have tower number 1, which we are going to label A, and then we have tower number 2, which we are going to label B. And then we have a cable which is supported on top of tower number A, and it runs to the top of tower number B. Why am I writing A and A? This is A, this is B. And obviously you can tell that the distance of the cable is longer than the distance between the towers. We can tell that by the sec. The distance from this part to this part we are going to label D. It's called the sec. It will be the sec of the cable below the top part of the tower. And then now, as it runs from tower number A to tower number B, it's going to have this point. We're going to say this is point O, and we call it the turning point. It's the turning point because from A it was going down, and then when it got to point O, it turned, and now it's going up. Then therefore this one is going to be the turning point. The distance of the tower, we are going to say this is YB. Obviously the other one is going to be YA because that one is A and this one is B. I'm going to use one side because they are the same, but if you were to label the other side, it's going to be YA. The distance between the towers, since we already made a mention of, is L. And the distance from the turning point to each tower, from here to here, it's going to be XB because this one is the B side, and then this side is going to be XA. From here to the turning point, and then from here to this side. Notice that we have a Cartesian plane, and then we are taking XX as our reference for when we are taking vertical distance. As you can see that the distance of the tower is taken from the XX line, meaning our XX is going to be the reference point. Therefore, the distance of the turning point from the reference line, which is XX, we are going to say it's YO. And already we can see that YB is equals to, in this case, YA. I'm saying in this case because it's possible to find a question where these two towers are not the same. So in this case, they are the same, and they will be equals to YO plus D, which is the sec and the distance of the turning point from the reference point. We can also see that L is equals to XA plus XB. The shape that is made by this cable is called catenary. The proper definition for catenary is the curve that a perfectly flexible and uniform cable, or it also can be a chain, assumes when it is hung between 2 points and supports only its own weight. So this shape is a catenary. But the conditions are this cable must be perfectly flexible and it must be uniform, meaning the cross-sectional area of the cable must be the same from this point to this point. And it must also be carrying its own weight only. If you add a load on this cable, the shape made then, it's no longer going to be catenary. But if you just hang the cable and let it collapse on its own weight, then the shape formed, it's going to be catenary. And those are the conditions. So whenever we're doing calculations, we're going to cut the cable into two, which will give us something like this. This is O. It's at the turning point. I'm still going to use the B side. This is at the top of the tower. I'm just going to write it B, top of B. We are doing tension in cable, meaning the one thing that we are most interested in are the tensions that are acting on these cables at any given point. We are going to have the weight of this thing. Weight is going down. And then we are going to have a tension pulling up like this, which is Ft. It's going to be Ftb on this case because we are dealing with the B side. If we were on the A side, it was going to be Fta. So don't get confused. And then we have a horizontal component here, or a horizontal tension, which is Fh. The forces at any given point of this cable are balanced. Why am I saying that, or how can I tell that they are balanced? It's because the cable is not moving. Meaning, at any given point of this cable, the forces acting on that point, which are these three, they are balanced, or they are in equilibrium, meaning the sum of all the forces is equals to 0. Therefore, if they are balanced, like we said, we can draw the triangle of forces to represent them, or we can represent them graphically like this, where this will be our W, this will be our Ft, and this will be our Fh. And we can tell that this is a right angle triangle. Let me remove this. And what's the one thing that we know about a right angled triangle? Pythagoras theorem. It's equals to, this is squared, W squared plus Fh squared. Ft is equals to y b times W, and the W that I am talking about is not the weight, is this one here, as the one that we have on this diagram, or this one. This is a small letter W, which represents the Newton per meter. This is the weight per unit length of the cable, and then this will be the total weight of the length of cable that we are dealing with. If we are here, let's call this point Z, then we are doing calculations about this point. We want to find the tensions on this point. We are going to take the length of the cable from the turning point to that Z point, and this weight will be from the turning point O to our point Z, whereas W will be the Newton per meter. So if you want to get this W, which is the capital letter W, you are going to say it is equals to W, which is the small letter W, times the length of the cable In this case, it will be from O to Z. Let's say it's 2. That's how we are going to get it. Therefore, our equation for W is equals to times the length. And then this one is going to be times W. We can therefore come back to our Pythagoras theorem and substitute. This will give us YB times W squared. And this one is going to give us Y times L squared. This one is going to be YO W squared. We have a W on this side, we have a W on this side. You can take W as a common factor here and then take W out from the brackets this side and then cancel out the W's on both sides of the equal sign, ending up with something like this. YB is equals to YB squared is equals to L squared plus Y O squared. Let's move this and look at the other formula that we have, which is the formula to calculate for X. Let's use XB. XB is equals to YO ln in bracket YB plus LB all divided by YO close bracket. We're calculating for XB. So if it was XA, then here it will be A and the length will also be length of A. In this case, it's not going to make a difference because they are equal. But if you are given a question with two supports that are of different size or different height, then it is going to make a difference. So it's very important that you understand what goes in here according to what you are calculating for. The main thing in this topic is to calculate for the tensions that are acting at any given point of the cable, and again is the distance between the two towers or two supports. We have to calculate for that. We're also going to calculate for this angle at that particular point which we are given. And the last thing we are going to calculate for mostly is going to be the length of the cable. And you can tell that according to these formulas, we said we're using the side of B. It tells you should have a clue by now that whenever we're doing calculations, we take these two sides separately. So we are going to cut the cable into two, something like this and this, and pretend that they are two different cables which we are going to take separately when we are doing calculations. So these are the formulas that we have. I want us to do a question, a simple question from the textbook. It's actually an example, so that we see how all of these simple equations get to be applied, how they ask questions, and how do you get to practice answering questions in tension in cables. This is the example that we are doing. I got it from my textbook, and it reads as follows. A cable is suspended between two supports on the same level. The length of the cable is 284 meters and the sag of the cable between the support is 30 meters. The weight of the cable is 25 Newton per meter. That will be our small letter W. And then the questions they say. Number 1, calculate for the maximum tension in the cable. Number 2, calculate the minimum tension in the cable. Number 3, calculate the maximum stress in the cable if the mean diameter of the cable is 80 millimeters. Number 4, calculate the slope of the cable at support B. And then the last question, they say calculate the distance between the supports. We have this diagram. We're given the sec as 30 meters. We're given the length of the cable from the top of support A to the top point of support B. And we said whenever we're doing a question, we're going to cut the cable into two. We cut it where? At the turning point. And one thing I forgot to mention is that this FH, as you can see, it is given by YO times W, small letter W. This FH is gonna be the same on each and every point of the cable. Anywhere in the cable, the horizontal component or the horizontal tension is going to be the same. And then FT will be controlled by the distance of the support or the height of the support. So if we were to calculate for the tension here, the distance of the support will be from the base or the reference point to here, which we can tell that it is smaller than the one on B. Therefore, it's going to be slightly smaller than the tension at the top of the support B. And that is how it is going to be. The maximum tension will be at the top of the tower, which will be at the top of B, and the minimum tension will be at the turning point. Question number 1, they say the maximum tension is at the top of this tower, which is tower number B. It's going to be the same at tower number A and tower number B because they are the same height and they are at the same level. So we're going to deal with only one side. We will get to the point where we're dealing with two towers of different height. You will see how that is going to go. We know FTB, it's equals to YB times W. We have this, but we do not have this. And we know that YB is equals to the sec plus YO. We have the sec, but we do not have YO. Therefore, let's say this is equation number 1. And then we move on and try to get YB using this formula. YB is equals to YO plus LB squared. LB will be the length of the cable from the turning point to support number B, the top of support number B, and it will be half because they are on the same level and they are equal, these two supports. It is going to be half of the total length of the cable, which is going to give us 142 meters. This will be our equation number 2. And then we are going to say substitute equation number 1 into equation number 2. We are going to take this and put here. It will give us YO plus the sec squared. It's equals to YO squared plus LB squared. Let's deal with this side first. It's going to be YO squared plus 2 times D times YO plus d squared, and then it's going to be yo plus lb squared, and then this is squared. This and this are going to cancel out, and then now let's substitute what we know on this equation. It's going to be 2, and we know that our d is given by what? We're given 30, and then it's going to be times yo. So simplifying this, we're going to end up with yo 30, no, 60. This is how we simplified that one. Then d squared is going to be, we said d is what? 30 squared. Then we move to the other side of the equal sign. We cancelled this out, and then we are left with this lb, which is 142 squared. The only unknown in this equation now is yo, so we are going to solve for yo. Let's remove some things here and create some space. Our yo, we make it the subject of the formula. It's going to be, this is squared, sorry, 142 minus 30 squared all divided by 60, and then put that on a calculator. We get that it gives us 321.067 meters. Remember, this is not what we are looking for. We are looking for yb, so we can be able to calculate for the maximum tension on the cable. And the maximum tension, we said it is found at the top of the tower. Yb is equals to d plus yo. This is 30. This is 321.067, 351.06067. Then from here we can be able to use that formula that we wanted to use. I'm going to write this here. yo is equals to 321.067 meters. Then I can erase this. It's still number 1. Our ft is given by yb, which is 351.067 times 25, and that will give us an answer of 8777 kilonewtons. That is how we answer the first question. I'm going to put this one here. YB is equals to 351.067 meters. Let's erase everything and do the second question. The second question, they say calculate for the minimum tension on the cable. Minimum tension on the cable is going to occur at the turning point. Number 2, FH is equals to W times YO. This is 25 times YO is 321.067 which is going to give us 8.027 kilonewtons. And then we go to the third question. They ask for the maximum stress in the cable if the mean diameter of the tension is 80 millimeters. The maximum stress in the cable will occur where the maximum tension is. Because the maximum tension, we said, it occurs at the top of the tower. Therefore, we're going to use that force to calculate for the stress on that particular point. We know that I did not write it down, but we calculated for FTP and we got it as 8.777 kilonewtons. That was the first question. So we're going to put it here, 8.777 times 10 to the power 3, all divided by pi times 0.08 squared. Let's not confuse each other. I'm going to put the 4 here. And then this will give us stress of 1.746 mega Pascal. Question number 4, they say the slope of the cable at point B. We are looking for this angle now. We can use tan theta. It's tau, meaning we're going to use opposite and adjacent. Opposite is this side, and then adjacent is this side. Let's hope I'm not deleting something that I'm going to need. Question number 4. We're going to use tan theta. It's equal. You can use n, you can use cos, you can use sine, as long as you have the information that you need and you are using the correct angle. You are calculating for the correct angle. It should come out as it should give you the correct answer. So we said it's going to be opposite, which is W. L. Adjacent is W. Y. O. This and this cancel out. So angle is equals to the inverse of tan LB, which is 142. YO is 3 to 1.067, close bracket, and then this will give us an angle of 23.86 degrees. The last question, they are asking us to calculate for the distance between the two supports or the two towers. Number 5, it's equals to L. No, it's not equals to. Number 5, we are looking for L, which is equals to XA plus XB. But in this case, XA and XB are the same. Therefore, we can calculate for the distance on one side and then times it by 2. Therefore, we're going to say XB is equals to YO ln open bracket YB plus LB divided by YO close bracket. Delete this. Substitute here. Our XB YO is 3 to 1.067 ln YB 2 as 351.067 plus 142 divided by yo, which is 2321.067, close bracket. Then that is going to give us 137.736. Then we're going to times it by 2 because they are the same, which will give us an answer of 275.472 meters, which is going to be the distance between the two supports. And this is going to be the end of our question, and that will bring us to the end of our lesson. I will see you on the next lesson.